All right, I want to start by just resurrecting your proof knowledge. So please look at this picture also on the front board. Oh, let's change that. Look at this proof and see how you would take it on. Got two triangles. We're given that angle 1 and angle 2 are the same, and that C is the midpoint of AE. And we're trying to prove that AB and ED are congruent. What's your first gut on this? 5. I know exactly how to do this. This is my bomb. 3. I could make a stab at this. I know how to start. I think I know where I'm going. I'm not sure I'd do it perfectly, but I'd be pretty close. 1. This is my nightmare right here. This is what keeps me awake at night. Okay. So for today's activity, I'd like to have the class participate, but each person only gets one contribution. So nobody's going to own the show here today. How should I start? Larry? Yeah.
Right there.
Angle 1 is congruent to angle 2, which you took from the given. And so what's our reason here? Given. Okay. What would be a good second point? Liam?
C is midpoint of line A. So
Good.
And then given.
Also given. Excellent. Was it important that I put this one first and this one second, or could they have gone in either order? It's not important. Either order would have been fine. Okay. What now? Anna?
You could put line AC is congruent to line CE.
Segment AC is congruent to segment EC. Huh, that's not in our givens. Where'd you get that?
If could you put if midpoint then congruent, or if I don't know how to word.
In other words, you're saying that you saw this word midpoint, you know that that means this. So what do we put there? Definition of midpoint. Okay. No, I have not been doing a trick I gave you guys to do to make things easier for us in the end. What should I be doing as I write things in here? Marking it on the picture. So angle 1 and angle 2, I'm going to mark those angles as congruent. Let me just get some color in here. And then we just came up with AC and EC. Do I have enough to be done? Only got 2. That's certainly not enough. How many do we need to prove triangles are congruent? 3. So I need another one. All right, Mac, what do you got? Which one? Okay, so you're going to say they are vertical angles first. Why do you get to call them vertical angles? Definition of vertical angles. Yep. So. Good. Why? Good. And we said they're vertical angles, so now we can say if they're vertical, then they're congruent. So that fits. And I'll mark that in my picture. What next? Declan?
rectangle or triangle ABC is congruent to triangle.
Wait, I'm going to hold your thought right there. I see where you're going. I like where you're going. He's named the first triangle ABC. Do you know how we're supposed to name the second triangle? Look up there, see what it would be without saying it out loud. What would be the matching triangle to ABC? Count of three, tell me the name of that triangle. 1, 2, 3. Good, EDC. Okay, I've got to make sure that the A matches with the E, the B matches with the D, and the C's match. And Declan, finish that off. Why can you claim these two triangles are congruent?
Angle, side, angle.
Angle, side, angle. From our picture, we can see that clearly. Please stop the whispering. Are we done? You've already gone, haven't you? Someone new, yeah. Nice, spelled correctly, well done. And what's the last thing, just to say we're done? QED. Good. 5. If I were asked to do that proof, I could do the whole thing myself. 3, as we as a group did it, I felt really confident about it. I understood it as we went. 1, I do not understand this stuff. Okay, hands down. Today, what I'd like to do is demonstrate how we might write a proof in a different format than 2 columns. There's a 2-column proof where our statements and our reasons are listed like a chart. But today, what I'd like to do is introduce this idea of a flow proof. And so I'm going to do a flow proof of the exact same theorem, exact same proof. How do I start? Again, with the givens. Angle 1 is congruent to angle 2. I put it in a box, and underneath the box, I write given. All right, now, second given. C is midpoint of segment AE. Where do I put the word given? Just below it. And what do we do next? We said, since this is a midpoint, what does that mean? It means that it's been split into 2 segments. So what's different in a flow proof is I make an arrow coming out of this fact and say this leads to a different conclusion, that AC is congruent to EC. And that's definition of midpoint. Now, what I'm aiming for here is to prove these triangles are congruent, right? ABC is congruent to triangle EDC. And in order to claim that this triangle is congruent, how many pieces have to contribute to it? 3. Here's one angle that's ready to go because I've already said this angle is congruent. And that's an angle that's in these triangles. Now I've got a side length that's, again, part of these triangles, AC and EC. What's the third fact I need to get my third chunk here? The vertical angle. So first I'm going to say angle BCA and angle DCE are vertical angles. What's my reason for that? Definition of vertical angles. And then leading directly from that fact, I want to say, if these angles are vertical, then they're congruent. So angle BCA is congruent to angle DCE. And is that my third fact I need to build these triangles as congruent? And when I look at my picture, I can see that it's ASA. And this is where I've achieved. I've worked all this stuff to get to here. One more step is to come out and say, what I really wanted was to say that AB is congruent to ED. And what's my reason for this? CPCTC. It does the same thing. It has all the same information, but it's in a different format. What do you think about this? Inevitably, there are some people who like it better. Who likes this format better than a two-column? 1, 2, 3, 4, 5. Hands down. Who's like, no. Two-column proof is the way to go. OG. 2, 3, 4, 5, 6, 7, 8, 9, 10. More there for sure. Who get them both and say they're interchangeable? You have to go either way. I mean, that's good. Nice. 5 or 6. Okay, good. They accomplish the same thing. They're both ways of writing a proof. Eventually, you'll get to choose. You can say, I prefer two-column proofs since I'm going to write this two-column proof. Or you can say, I like the visual spatial demonstrating what comes into it to show you where it comes from instead of making you understand where it comes from context. For now, I'll ask you to do a couple of these things. Specifically, I'll ask you to do a flow proof or a two-column proof. Today, we're going to work with proving a theorem specifically. Hang that up. It's a theorem you guys have used before. Do you remember the Isosceles Triangle Theorem? What does the Isosceles Triangle Theorem say? You guys remember this? We did some problems where I would give you a picture and show that these two sides are congruent. And then I'd say that if this angle is 68, how big is this angle? Right? If one pair of sides are congruent, then the base angles are also congruent. Do you remember this? We're going to prove it. In order to prove this, I need to give myself a picture with letters or numbers or whatever, so that I can be specific. And I want to start with this. What's my given? Oh, sorry, let's make that a C. What's my given? If I'm trying to prove this theorem, if this, then this. Julie? Hold on, Julie. Good. We want to start with it being isosceles. AB is congruent to BC. And what are we trying to prove? Give me someone new. You guys have already gone. You've gone. You guys have gone. Give me someone new. Sai, what about you? AB is congruent to AC. Is that what this picture would show? Hi, Maya? Really close. It is angle. What do we call this angle? Can we just call it A? And what do we call this one? So this is what we're trying to do, right? We're saying that if I've got this triangle with AB and BC the same, I want to prove that this angle A and this angle C are the same. Can I just send you guys off to do this now? Prove this. Something's missing. What's wrong? Why is this different than any proof you guys have done in proving triangles are congruent? Jacob, put your phone away. You guys are accomplished at something now with triangles, right? What can you do with triangles and congruence? You can prove that how many triangles are congruent? 2. Do you have 2 triangles here? So you don't have any way to do anything if you don't have 2 triangles you're trying to prove congruent. Can we turn this into 2 triangles? How? Split it in the middle. Is that what I heard? So in the world of geometry, splitting a triangle in half has to be more specific than that. Can we agree there is a bisector for an angle and there's a bisector for a side? Can we agree that what we're talking about is this segment BX? But if you have to tell somebody exactly what to do with this BX, what do you want this BX to be? Okay, it's going to be in the given, but BX is what? A bisector? What kind of bisector? Yeah, we don't have a thing called the triangle bisector. It's clever. Maybe we should have one, but we don't yet. What would have to be true about this BX for you to say, that's cutting it right in half? Yeah. Good. So that's called a median, where we say that if BX is a median, then we know that the next step is, okay, what's a median say? Well, that means that it's in the middle here. So AX and CX are the same. Do you guys agree that would do it? Is there something else I could say instead of median? Julia, you want to take the packet? Guess not. What else would split this in half besides making this hit the midpoint there? When you're drawing this angle, how would you draw this line so that it goes right through the middle? A compass, okay. And you'd use the compass to do what? Make it perpendicular to this side?
Yeah.
Okay, good. So that's called an altitude. And that's a second way we could do this. A, B, C. If we made sure that this line came out of B and came straight down to make a right angle, that's called an altitude. There's a third one. How else could I split this thing so it looks right down the middle? It's got to do with up here. Yeah, River.
Make the angles on B congruent.
Good. Bisect this angle, right? Split it exactly in half. It could be an angle bisector. And that's the third one, would be okay, so let me do this now. Which one says share screen? Is that this one? Does that say share screen? Thank you. I can't see it from here. That didn't work so well. Okay. So we're going to do the first one with an altitude. We're going to say, if I have an isosceles triangle with an altitude, hold on one second, I'm not so sure I'm actually sharing the right screen. That's what I want. Okay. So if I've got an isosceles triangle with an altitude drawn, BX specifically is an altitude now, then I'm going to prove that my base angles are congruent. I'm going to do this as a flow proof. How do I start? Given, so I'd say AB is congruent to CB, given. Then I'd bring in my second given, BX is an altitude. Now, I've written two things in here, but I've only got one set of marks in my picture. Why is that?
Line BX.
Line BX is going to come help us for sure, but why don't I have anything for this red marked in here yet? I've got this marked, AB and BC. Why don't I have anything for this marked? Mac? I mean, we can bring in the reflexive property. You guys are both saying the same thing, that BX is congruent to BX because of reflexive, and I can mark that, but I still can't mark this. Why can't I mark this? Little more. We do have to prove the triangles are congruent, but this is going to contribute to our third fact, isn't it? I can only mark facts that are congruent or things that contribute to our proof. AAS, ASA, SAS, SSS, RHL. So I got to do something with this altitude. I said it was an altitude, but what good is that for me? Those are ready to go, but this one I got to find out what an altitude is. So what does an altitude mean? Well, the definition of an altitude is that BX is perpendicular to AC. Okay, but what does perpendicular mean? Well, that means it makes right angles. BXA and BXC makes right angles. And with that right angle, now do I have enough to say that my triangles are congruent? Mac, don't say it. What would you say that to prove the triangles are congruent? What goes here? Come on. S, what is it? Is it ASS? It is ASS, isn't it? Angle side, side, and this right angle side, side. Is that one of the theorems that proves triangles congruent? It's not. We're not allowed to say that one in math. Ooh, ASS. But this ain't any old A. This is a right angle. RHL, very good. RHL, some people call it HL. I call it RHL because it's still got three facts. You have to have a right angle, you have to have the hypotenuse, and you have to have a leg. With those three components, I'm able to prove the triangles are congruent and then prove the components are congruent by CP, CTC. How's this feel? 5. I think I get this. I could prove this. 3. I'm not really familiar with these specifically, what the altitude is and how that works, but I think I get the idea with a little nudge. 1, still totally worthless. I can't do this. Good. All right. What I'm going to do is I'm going to pass out in a moment your worksheet for today. And it's going to begin with this proof. And I want you to copy this down into the notes. And then you'll transcribe it to a 2-column proof. And then you'll do the same thing with a median. So please watch for a second as I do this median. How's this one going to be different? Still given, still reflexive, and still median. I've got my 2 facts. What do I do to make this a usable fact? Define what a median is. Well, a median means it goes to the midpoint of the opposite side. Goes from B to X, which is the midpoint. That doesn't really help me yet. What else should I define? If I define the midpoint as AX and CX, that tells me that X is in the middle. Now I've got what I need. These 3 facts are enough to prove my triangles are congruent. This time by what? Not RHL. This time it's side, side, side. Everything else is the same except for these little definitional parts and what theorem I'm choosing. What if I did it with the angle bisector, the third way you guys came up with? Still start with my given, my reflexive, and my other given. What now? Definition of angle bisector. What does that mean? Well, that means these angles are congruent. Okay. Are these 3 facts enough now? in my picture, I can see what's it going to be? SAS. These three facts build here to SAS. That lets me go with my CP/CTC, say done. So generally, all of them are done like this, right? It's only a question of you claim what Bx is. Is it an altitude? In which case you define altitude, and it's RHL. Is it a median? In which case you define median, you get SSS. Is it an angle bisector? You define angle bisector, you get SAS. Okay, I'm going to pass out the worksheets now. What you'll find is a couple of proofs. You should write them in flow proof and 2-column as it says. And then the last couple pages are some Halloween logic puzzles. There's 4 total logic puzzles. I only need you to do 2. You pick which ones you want to do in celebration of Halloween.